Hello, everybody. Today we will be solving problem 11 of the 2021 AIME II. The problem reads, a teacher was leading a class of 4 perfectly logical students. The teacher chose a set S of 4 integers and gave a different number in S to each student. Then the teacher announced to the class that the numbers in S were 4 consecutive 2-digit positive integers, that some number in S was divisible by 6, and a different number in S was divisible by 7. The teacher then asked if any of the students could deduce what S is, but in unison all of the students replied no. However, upon hearing that all 4 students replied no, each student was able to determine the elements of S. Find the sum of all possible values of the greatest element of S. Okay, it turns out there aren't that many possible values of S. So I've gone ahead and listed every single set of 4 consecutive 2-digit positive integers with a multiple of 6 and a different multiple of 7. Right, and you can count there are only 20 some number of them, so it should only take you really 3 minutes to write all of them down in an AIME test. Okay, and let's suppose for a moment that the students are named A, B, C, and D. Okay, and let's suppose that the set S is 11, 12, 13, 14. Okay, and it doesn't matter which order the students get the slips of paper in. So without loss of generality, we're going to give 11 to A, 12 to B, 13 to C, and 14 to D. Okay, then the teacher's going to announce what she announced. And then, okay, let's suppose for a moment that we're student A, and we see this slip of paper 11. And then, since A is perfectly logical, A knows that these are the only sets that satisfy all of the requirements the teacher gave them. And then A looks and then realizes 11, 12, 13, 14 is the only set that satisfies everything the teacher said and has the number 11 in it. Which means that A, when the teacher asks if any of the students can deduce what S is, A is going to say yeah, because this is the only possible value set S with 11 in it, right? So A is going to say yeah, I know what the set is. And more generally, if you have a set and there's one element in the set that's not in any of the other sets on this list, we can eliminate it. So for example, we can eliminate this one. Then we can look at this set 12, 13, 14, 15. And then we realize whoever gets the number 15 can immediately be like, okay, this set is the only one in the list with 15 in it. So this must be the correct one. So we can eliminate this one. And then this third one, whoever gets 18 can deduce it. There might be more than just one person, but if you can find one person that says yes, we can eliminate it. Then this next one, there is the number 24. The next one is 27. I'm just listing one number that would nullify each set. This one, 31. This next one, 33. This next one, I can't cross it out yet. The next one, there's a 38. The next one, there's 46. The next one, I can't say anything about. The next one, there's a 51. The next one, there's a 53. The next one, there's a 57. It really shouldn't take more than 1 or 2 minutes to do this on an AIME test. This next one, there's a 60. This next one, there's a 66. This next one, there's a 69. This next one, there's a 73. And this next one, there's a 75. Then the following one, we can't say anything about. Then we have one with an 80, an 88. This one, we're going to keep on here. This next one, 93. Then the next one's 95. And the next one's 99. And what we've done is we've reduced it to 4 possible sets. And I'll use a different color. 34, 35, 36, 37. And 47, 48, 49, 50. And then there is 76, 77, 78, 79. And then there is 89, 90, 91, 92. And I'm going to claim that all of these sets work. Okay, so I'm going to use this set 34, 35, 36, 37 as an example. And then my argument is going to carry over for each of the other four sets. Okay, so A, B, C, and D get those four numbers. And again, order doesn't matter. So without loss of generality, we're going to give 34 to A, 35 to B, 36 to C, and 37 to D. Okay, then the teacher tells them what the teacher is giving them in the problem. And then the teacher asks if any of the students can deduce what S is. And all of them are going to say no. A is going to look and be like, okay, 34, it's in one of these two sets. 33, 34, 35, 36, 34, 35, 36, 37. And he hasn't eliminated them yet because he hasn't heard everyone else say no. But as soon as he says, he hears everyone else say no, he realizes that this set 33, 34, 35, 36 isn't S, because if it was, then whoever had 33 would say yes. So A's logic is going to be, okay, we are going to cross this one out, and the only remaining one is 34, 35, 36, 37. So A says yes after everyone else says no. Similarly, B looks and says, okay, 35, it's in these three sets, 33 to 36, 34 to 37, 35 to 38. Okay, and this is before everyone says no. But then as soon as everyone says no, he realizes can't be this one because whoever had 33 would say yes. Can't be this one because whoever had 38 would say yes. So it must be this one. And similar arguments hold for C and D. And then we can say the same thing about set 47, 48, 49, 50. The set 76, 77, 78, 79, and the set 89, 90, 91, 92. As soon as each student hears everyone else say no, they're going to be able to cross out all of the sets their numbers in except for one, which means that we just have to find the sum of the greatest value of these four sets. And the answer is 37 plus 50 plus 79 plus 92, which is equal to 258. So that's our answer. Thanks for watching, and I'll see you in the next video.